Hello guys, welcome back to the channel. Today I have a fun integral to try, so let's just dive straight into it. Cool, so here's the integral, and I prepared a hint, so I'm just going to pause for a moment if you want to try without the hint. Cool, so the hint I prepared is to add 0 creatively, so that might help you with the integral. Cool, so let's dive straight into it. So I think the first thing to recognize is we have a top-heavy fraction, which just means that the highest power of x is on the numerator rather than the denominator. And there's a nice thing we can do, which is using the hint straight away. If we add x squared and subtract x squared, as well as add x and subtract x, and then we can split up our fraction like so. We can then simplify this right chunk here just down to x. And then using the same trick, we can add 1 and subtract 1. And being careful with our negative sign, so putting things in brackets, we can then simplify down to this integral. So clearly we've made progress, but there's still some work to be done. And I think a nice thing here would just be to split up the integral into 2 chunks and then integrate the left side because this is quite standard. So just integrating with polynomials, remembering our bounds as well. That's an important detail. And if we sub in our values, we will get to minus a half. And then I'm going to put this minus a half in a purple box because that's part of a solution. And so now I can just focus on this 1 over x squared plus x plus 1 dx. Cool. A nice thing to do from here is to complete the square, just like so. And then some of you guys might be able to integrate straight away from here. You might recognize the pattern and use this formula. But if you don't recognize that, I will show you a proof and how to do it without just memorizing a formula. But otherwise, feel free to skip ahead. Cool. So if you're staying with me, we can use the substitution of x plus 1 is equal to u and chuck a box around it because it's a new variable. And if we differentiate both sides, we get dx is equal to du. And then we can sub out for x plus a half u, just like so, and then sub out for dx du because they equal each other, just like so. So now we've dealt with this faff of having plus a constant here. And then the next thing we can do is another substitution of u is equal to root 3 over 2 tan v. And you'll see why we use this substitution. But if we chuck a box again because it's a new variable and we differentiate both sides, we get du is equal to root 3 over 2 secant squared v dv. And then using these ingredients, we can sub it into our integral. So we know u is going to equal this chunk and du is equal to this. So if we just sub it all in, and then we get to this nice area here now where we have 3 over 4 tan squared v plus 3 over 4. And that's why we use the substitution with root 3 over 2 because we wanted to have a matching coefficient as we have a constant on the denominator. And then using this trig identity, if we divide both sides by cos squared, we get here, and times both sides by 3 over 4, we get here. And so we can clearly see our denominator just equals 3 over 4 secant squared v, being careful with our variables, just like so. Nice, so from here, the secant squares will just cancel out, and we already saw that root 3 over 2 is the square root of 3 over 4, so if you divide carefully, you'll get 2 over root 3 dv. And then integrating here is pretty simple, just integrating with polynomials. Just imagine a v to the 0. And then what we want is we want to have our solution in terms of x, because that's what we started off with. So I'm just bringing back the substitutions here. And if we do some work, starting off by making v the subject, so timesing both sides by 2 over root 3, and then inverse tanning both sides. And then we sub out for u x plus a half, just like so. We have an expression of x in terms of v. And so now we can sub that in, remembering our bounds as well. That's an important detail. And then we can sub in our bounds. So 1 plus a half is 3 over 2, and 0 plus a half is just a half, just like so. And bringing back our minus a half, which we solved earlier, and tying it back into our solution. And now it's just a matter of simplifying. So these 2's here will cancel out, and 3 over root 3 is just root 3. And these 2's again will cancel out, and you're left with 1 over root 3. And then luckily arctan root 3 is just pi over 3, and arctan 1 over root 3 is pi over 6. They're known values. That's quite nice, which we can then simplify like so. And then if we rationalize, we get here. And that is our final answer, so we can check a box around it. I hope you enjoyed the solution, and if you fancy solving more integrals, feel free to check out my playlist in the description below. Thank you for watching.